So this is 2021 ADDMA paper 2 question 10. The velocity of a particle moving in a straight line t seconds after passing through a fixed point O is given by v is equal to 3t minus t squared. The particle comes to instantaneous rests at P. Find the time taken to reach P. So at instantaneous rest, the velocity is always equal to 0. This should always be in your head. So v is equal to 3t minus t squared. And then when an object is instantly at rest, it's not moving. It means the velocity is 0, not the time. I always emphasize on this, because the time will always be moving. Whether you stop moving, you start moving, the time will always be moving. So now we can solve for t, and the easiest method here is factorization. You can just factor out the t. You can use the formula, you can complete the square, but I think this is the easiest. So either t is equal to 0 or 3 minus t is equal to 0, which means t is equal to 3. So now this one will be rejected. You can just say nah, or not applicable, not acceptable, or not admissible. So we just want this. Why is this one rejected? Because this is the time when the object is just getting started at the starting point. So this is like the origin. And then this is the only possibility. And then acceleration at P. So to find the acceleration at P, remember from acceleration, let's start with the distance. When you have the distance, to get the acceleration, you differentiate. To get the velocity, you differentiate. In other words, you're just dividing it by t. And then to get the acceleration, you differentiate this. So you have acceleration. And then to move backwards, you have to integrate. So when I integrate this, I'll get this. When I integrate this, I'll get this. So to get the acceleration from the velocity function, 3t minus t squared, you can just differentiate this. So dv dt will be 3 minus 2t. And then we want to find the acceleration at P. So we know that at P, t is equal to 3. So you can just say a is equal to 3 minus 2t, and then find a of 3. So this one will be 3 minus 2, and then you put your 3 there. So this will be 3 minus 6, which would be negative 3. So our acceleration is 3 meters per second, negative 3 meters per second. And then finally we have the distance, OP. Find the distance, OP. So we have the velocity function. To find the distance function, we have to integrate with respect to t. So our v is equal to 3t minus load shading. So 3t minus t squared. So once you integrate this with respect to t, this will give you s, which is the distance, and then this one will be 3t squared over 2, and then this will be t to the power 3 over 3, and then plus c. So now let's go back to the opening statement to find our c. So we have something here, t seconds after passing through a fixed point O. So this one tells you that it passed through the point O, which is called the origin. So the origin, the coordinates for the origin are 0, 0. So that means our C is 0, but you can always find it by substituting so this one is your T and this is your S. So you can put your 0 there, and then your 0 here, and then your 0 there, and then your C there. You realize that all these will be zeros, and then our C will be 0. So the distance function will be 3 over 2 t squared minus t cubed over 3 plus nothing. So this is our S. And then, of course, we are not trying to find this. We want to find the actual distance from O to P. And then from part A here, we know that at at P, time is equal to 3 seconds. So we can use this to find our distance. So S is equal to 3 over 2. Where you have this, just put your time, which is 3 seconds, squared, minus, you put another 3 cubed, like this. So this one squared is 9 times this, we have 27 over 2. And then this one is 27 divided by this is 9. So that we have 27 minus, of course we have our common denominator, minus 18, which is like 17 minus 8. So 2, that's a 9 over 2, which is like 4.5. So you can either leave it like this or like this, and these are meters. Although I don't really think it's necessary to include the units here. Okay, enjoy the rest of the day.